The first reaction, alkyl halide treated with KCN and DMSO, dimethyl sulfoxide. And dimethyl sulfoxide is polar aprotic solvent. Dimethyl sulfoxide, polar aprotic solvent. So when we see this reaction, simply we should recollect our reaction when alkyl halide treated with KCN, because cyanide is ambident nucleophile, therefore it gives cyanide plus isocyanide. Cyanide plus isocyanide, and cyanide is major product. Cyanide is major product and it undergo SN2 reaction. That's why we are preferring polar aprotic solvent. First we have to recollect this point. Second point is double bond connected to leaving group, triple bond connected to leaving group, benzene connected to leaving group, cyclopropane connected to leaving group, and bridge carbon connected to leaving group. So these molecules, when we add nucleophile, they do not undergo nucleophilic substitution reaction. They do not undergo nucleophilic substitution reaction. సో ఈ 2 పాయింట్స్ని మనం దృష్టిలో పెట్టుకుంటే ఇక్కడ మనకి టెర్షరీ బ్రిడ్జ్ కార్బన్ కాబట్టి ఇక్కడ రియాక్షన్ జరగదు. ఈ పార్ట్ అనేది రియాక్షన్ పార్టిసిపేట్ చేయదు. సో ఓన్లీ పాసిబిలిటీ ఏంటంటే మనకి క్లోరిన్ లీవై కరెస్పాండింగ్ సైనైడ్ ఫామ్ అవుతుంది. SN2 రియాక్షన్ జరిగి సైనైడ్ ఫామ్ అయింది. సైనైడ్ అనేది మనకి మేజర్ ప్రొడక్ట్. దిస్ ఈజ్ అవర్ మేజర్ ప్రొడక్ట్. So it is a structure of A. Now it is treated with diisobutyl aluminum hydride dibal. Diisobutyl aluminum hydride dibal. సో ఇక్కడ మనకి 2 ఫంక్షనల్ గ్రూప్స్ ఉన్నాయి. ఒకటి ఆల్కైల్ హ్యాలైడ్ అండ్ ఇంకొకటి సైనైడ్. సో మనం చదువుకున్న సిలబస్ ప్రకారం ఆల్కైల్ హ్యాలైడ్కి డైబాల్ హెచ్తో రియాక్షన్ తీసుకోం, సైనైడ్కి డైబాల్ హెచ్ రియాక్షన్ తీసుకుంటాం. సో సైనైడ్కి డైబాల్ హెచ్తో రియాక్షన్ తీసుకుంటే సింపుల్గా హైడ్రాలసిస్ గ్రాంటెడ్గా తీసుకుంటే cyanide will be converted to CHO. Hydrolysis granted తీసుకుంటే cyanide will be converted to aldehyde. Therefore, here also cyanide group will be converted into corresponding aldehyde. Now, this product treated with secondary amine and H2PD. Secondary amine and H2PD. So here 2 possibilities are there. One possibility, alkyl halide treated with amine. So we expect SN2 type of reaction. Possibility. But here it is a bridge carbon. So bridge carbon do not participate in the SN reaction. That is not possible. Second one is when aldehyde treated with, for example, CH3CHO treated with secondary amine. Initially nucleophilic addition takes place. And finally dehydration takes place. And corresponding enamine is formed. But it is treated with, in the presence of H2PD, it undergo reduction and finally it forms corresponding amine. Finally we got amine. So this entire reaction is known as reductive amination. So similarly in this case also nucleophilic addition takes place. After that corresponding reduction takes place, and finally we can write the product like this. Finally we can write the product like this. సో మనం ప్రీవియస్ రియాక్షన్తో కంపేర్ చేస్తే ఎక్కడైతే ఆల్డిహైడ్ గ్రూప్ ఉందో అక్కడ మనకి ఈ నైట్రోజన్ గ్రూప్ అటాచ్ అయింది. సో మనకి ఆల్డిహైడ్ గ్రూప్ ఉన్న దగ్గర నైట్రోజన్ గ్రూప్ అటాచ్ చేసాం. సో దిస్ ఇస్ ద స్ట్రక్చర్ ఆఫ్ సి. The reactant is cinnamic acid. It is called cinnamic acid. Cinnamic acid. When cinnamic acid treated with SOCl2, సో ఇక్కడ మనకి ఫంక్షన్ గ్రూప్ చూడంగానే మనకి గుర్తుకు రావాల్సింది కార్బాక్సిలిక్ యాసిడ్ when treated with PCl5 or PCl3 or SOCl2, the corresponding OH group will be replaced by chlorine. So nucleophilic substitution reaction. So in this case also we have to consider nucleophilic substitution reaction. You can say cinnamyl chloride. Cinnamyl chloride. Now the cinnamyl chloride is treated with ammonia. And we know that ammonia is nucleophile and here chlorine group is present. So definitely nucleophilic substitution takes place. Nucleophilic substitution takes place and corresponding cinnamide is formed. Corresponding cinnamide. Now the cinnamide treated with H2PD. So this reaction is catalytic hydrogenation. And we know that catalytic hydrogenation, acid, ester, amide and epoxide. Acid, ester, amide and epoxide. So these functional groups do not undergo reaction, do not undergo catalytic hydrogenation. So that's why here amide group will not be reduced, but alkene group will be reduced with H2PD. So alkene group reduce అయితే corresponding amide will be formed. సో మనకి ఇక్కడ ఉన్న ఆల్కిన్ పార్ట్ అనేది రెడ్యూస్ అయింది catalytic hydrogenation. And we know that catalytic hydrogenation is always exothermic. And heat of hydrogenation, this is called heat of hydrogenation. And heat of hydrogenation directly proportional to number of pi bonds, indirectly proportional to stability of alkene. Stability of isomer, you can also say stability of isomer. First one is cyanide. And cyanide treated with NaOH and H2O. సో మనం ఈ రియాక్షన్ చూడంగానే గుర్తుకు రావాల్సింది సపోజ్ cyanide NaOH H2O heat, then it undergo complete hydrolysis. And we have to break the bond here. Simply we should write carboxylic acid and ammonia. Suppose cyanide treated with NaOH H2O, but the heat is not given, then it undergo partial hydrolysis. So partial hydrolysis, nucleophilic substitution takes place, and after tautomerization finally it gives corresponding carboxylic amide. So cyanide NaOH H2O heat undergo complete hydrolysis, and cyanide heat is not given, undergo partial hydrolysis. So in the given question heat is not given, therefore cyanide undergo partial hydrolysis. Cyanide undergo partial hydrolysis. It gives finally corresponding primary amide. Primary amide. Now the primary amide treated with Br2NaOH. Br2NaOH. And we know that primary amide when treated with Br2NaOH, this reaction is Hoffman bromamide reaction. Hoffman bromamide reaction. It is Hoffman bromide reaction. Therefore, the corresponding CO group should be eliminated and you should write simply RNH2. You should write simply RNH2. It is Hoffman bromide reaction. And here retention in configuration. Retention in configuration. Okay, so that's why simply here we can write simply corresponding primary amine. Corresponding primary amine. And third reaction, chloroform and KOH. So primary amine treated with chloroform and KOH, and here we use alcoholic KOH. So this reaction is when primary amine treated with chloroform and alcoholic KOH. Alcoholic KOH. This reaction is known as carbyl amine reaction. This reaction is known as carbyl amine reaction. Therefore, it will be converted to RNC. RNH2 will be converted to RNC. Primary amine will be converted to corresponding isocyanide. It is called carbyl amine reaction. Therefore, here simply this NH2 group will be converted into isocyanide. Isocyanide. So this is a carbyl amine reaction. సో ఇక్కడ మనం రివైజ్ చేసుకున్న రియాక్షన్స్ సైనైడ్ కంప్లీట్ హైడ్రాలసిస్. ఇన్ కేసు సైనైడ్కి కంప్లీట్ హైడ్రాలసిస్ చేస్తే మనకి కార్బాక్సిలిక్ యాసిడ్ అండ్ అమోనియా పార్షియల్ హైడ్రాలసిస్ చేస్తే అమైడ్ ఫామ్ అయింది. ఫస్ట్ రియాక్షన్. సెకండ్ రియాక్షన్ హాఫ్మన్ బ్రోమైడ్ రియాక్షన్. సో ప్రైమరీ అమైడ్కి Br2OH మైనస్ యాడ్ చేస్తే మనకి సింపుల్గా కరెస్పాండింగ్ ఎమీన్ టైప్ కాంపౌండ్ ఫామ్ అవుద్ది. ఇక్కడ మనం రిటెన్షన్ ఇన్ కన్ఫిగరేషన్ ఫాలో కావాలి. అండ్ థర్డ్ వన్ కార్బైల్ ఎమీన్ రియాక్షన్. సో ప్రైమరీ ఎమీన్ విల్ బి కన్వర్టెడ్ ఇంటూ కరెస్పాండింగ్ isocyanide. And of course we know that isocyanide has a foul smell, so it is also useful for testing primary amine. Isocyanide has a foul smell, not good smell, therefore we can easily say that amine is primary amine. The first reaction is 6-membered ring and corresponding OH group, alcohol part, and the same carbon also connected to corresponding primary amide. Now it is treated with NaOBr. NaOBr. So when we see this reaction, immediately we have to recollect our reactions. When primary amide treated with NaOBr, we can use NaOBr, we can use Br2OH minus, we can also use Br minus plus BrO3 minus, and we can also use Br2 plus CO3 minus 2. So any combination we can use. So here what happens, simply we have to remove the CO group and write down the corresponding amine. So this reaction is Hoffman bromamide reaction. This reaction is Hoffman bromamide reaction. And here obviously we observed retention in configuration. Retention in configuration. Therefore, here the product we can write directly below the plane OH, above the plane NH2. Below the plane OH, above the plane NH2. But if the same carbon connected to OH group and NH2, so simply remove the ammonia and write down corresponding thermodynamically stable compound ketone. Thermodynamically stable compound ketone. So it is a first product. It is a product A. Now the product A treated with zinc mercury conc HCl. Zinc mercury conc HCl. So it is simply Clemmensen reduction. It is simply Clemmensen reduction. So in the Clemmensen reduction, what happens? The keto group will be reduced to corresponding alkane part. The keto group will be reduced to corresponding alkane part. It is a Clemmensen reduction and it is a structure of B. Now the structure of B treated with Cl2H nu. So it is completely, B is completely alkane. Alkane treated with Cl2H nu. It undergo free radical substitution. It undergo free radical substitution. Therefore, the corresponding products are, so chlorine can substitute at all positions. So these are the possible products with respect to structural isomers. These are the possible products with respect to structural isomers. So here how many products are formed? Here one product and here also one, and here we are having two chiral centers. Therefore, RR configuration, RS configuration, SR configuration, SS, total 4 compounds. Similarly, here also two chiral centers. In this case also, we are getting RR, RS, SR and SS. Here also we are getting 4 products. And here there is no chiral center, but here we can expect geometrical isomers. Here we can expect cis plus trans. Two isomers we can expect. Cis isomer and trans isomer. So the total products are here monochloro products. If I consider only monochloro, total 13. 13 products are formed. సో ఈ రియాక్షన్ మనం రివైజ్ చేసుకుంది హాఫ్మన్ బ్రోమైడ్ రియాక్షన్. Primary amide will be converted to primary amine. Clemmensen reduction, aldehyde ketones will be converted to alkane, and alkane treated with halogen undergo free radical substitution. So this reactant treated with HNO2. Treated with HNO2. So here if you see the entire structure, here we are having NH2, and we know that one of the basic reaction when primary amine treated with HNO2, initially it will be diazotized and aliphatic diazoxime salts unstable. It converted into R plus. Finally, it gives corresponding alcohol type compound. It is for simple primary amine. And here, after losing, so here also in place of NH2, we can write N2 plus, and N2 plus removed, and finally it forms carbocation. Finally, it forms corresponding carbocation. Now here migration possible because octet possibility is there. That's why if octet possibility is there, pH minus will migrate than R minus. So మనకి pH minus migrate అయితే corresponding product like this. And here resonance is possible. After writing resonance, we can remove the proton and finally we get corresponding ketone. Finally, we get corresponding ketone. So this is also called semi-penacol-penaclone reaction. This is also called semi-penacol-penaclone reaction. Name of the reaction not that much important, but we can follow the mechanism. It is a structure of A. Now it is treated with CaOCl2. CaOCl2. సో ఇక్కడ మనకున్న ఫంక్షన్ గ్రూప్స్ వచ్చేసి NO2 ఫంక్షన్ గ్రూప్ ఉంది అండ్ కీటోన్ ఫంక్షన్ గ్రూప్ ఉంది. అండ్ ఇట్ ఈస్ అ బ్లీచింగ్ పౌడర్ కాంబినేషన్ CaOCl2. సో మనకి గుర్తుకు రావాల్సిన రియాక్షన్ ఏంటంటే ఆల్రెడీ కీటోన్స్ చాప్టర్లో ఫర్ ఎగ్జాంపుల్ కీటోన్ treated with Cl2 and OH minus, OCl minus, Cl minus plus ClO3 minus and Cl2 plus CO3 minus 2. So any halogen we can take. So it is simply haloform test. It is simply haloform test. So from bleaching powder we get CaOCl, OCl minus. From bleaching powder combination we get OCl minus. Therefore here what happens simply it undergo haloform type of reaction. Finally it gives corresponding carboxylate ion and chloroform. కార్బాక్సిలేట్ అయాన్ అండ్ క్లోరోఫామ్. సో ఈ CH3 పార్ట్ అనేది క్లోరోఫామ్కు కన్వర్ట్ అయింది. ఈ CH3 పార్ట్ క్లోరోఫామ్ కన్వర్ట్ అయింది. సో ఇక్కడ కూడా మనకి CH3 పార్ట్ ఉంది కదా. సో ఈ CH3 పార్ట్ అనేది క్లోరోఫామ్ కన్వర్ట్ అవుతుంది. So it is a structure of B. It is a structure of B. And the structure of B treated with soda lime. So it is a structure of B. It is treated with soda lime. NaOH, CaO, heat. So soda lime basic reaction is when carboxylic acid treated with the soda lime. So we should remove the CO2 and write down the C minus. If no other possibilities, acidification granted. Finally, it gives corresponding alkane type. So in this case also, remove the CO2, write down the C minus. Other possibilities are not there. Therefore, I am considering acidification grantedly. I am considering acidification grantedly. So this is a final product. This is a final product. It is a structure of C. Structure of C.